Welcome to the video lecture of Computer Networks. I am Sujita, Assistant Professor, Department of Computer Science Engineering, NPR College of Engineering and Technology, going to present this video lecture. So in this video lecture, we are going to discuss about a topic called OSI model. So it is a very important concept in a computer networks. So it comes under the unit introduction and physical layer, unit 1. So let me discuss about the OSI model in detail. So first one is the introduction about an OSI model. So before the OSI model, we have using an TCP/IP protocol, but this protocol does not define the this protocol is not only suits for the protocols defined. So it was developed in the ISO by 1947 for the worldwide agreements of an international standards. So that ISO, it doesn't cover the TCP/IP suite of protocol suite. It doesn't covers and all the aspects of protocols in the networks. So to cover all the aspects, of a network communication, we have the OSI. The ISO developed an model called OSI model, that is we can call it as an open systems interconnections. So it was first introduced in the year of 1970s. So what is mean by this OSI model? So in this OSI model, the open system, what is mean by this open system? So open system is a set of protocols that allows any two different systems to communicate regardless of their underlying architecture. The main purpose of an OSI is to show how to facilitate the communication between the different systems without requiring any change to the logic of the underlying hardware of the software. So the OSI is not a protocol, it is a model for understanding and designing a network architecture that is more flexible, robust and interoperable. So it doesn't not define any rules, but it defines how to design and how it should be in a good architecture. So that should be how it is to work. That are all the things that the OSI model will cover. So the OSI model is a layered framework. Here we are going to see everything in a layered architecture. So that is why in the previous topic we have discussed about a protocol layering approach. So in this the OSI model, here everything will be concerned about with the layered framework for the designing of the network systems that allows communication between all types of computer systems. So it consists of 7 separate layers. Each of the layers will defines the process of moving information across the network. So each layer will defines how this process will be used in a network. So we will be discussed each layer in a detail. So these are all the 7 layers of an OSI model. From bottom to top we'll be having in 7 layers. The first layer is a physical layer, the second one is a data link layer, third one is a network layer, fourth one is a transport layer, fifth one is a session layer, sixth one is a presentation layer, and seventh one is an application layer. So we will discuss each layer and how the layer influences in the communication over the network. So before we are going to discuss about layers in detail, we will discuss what is this layered architecture. So this layered architecture will compose into 7 layers, 7 ordered layers, physical, data link to application layers. So the layers are involves to send messages from device A to device B. Consider 2 devices that are device A and device B. So these layers are mainly influences to transfer the messages from device A to device B. So as the message travels from A to B, it may passes through several intermediate nodes. So these intermediate nodes usually involve only in the first three layers of the OSI model. So the other layers does not have any intermediate layers, that all having the peer-to-peer process. So only the first three layers will have the intermediate nodes. So the complete OSI model will above the interoperability process. Next, what is meant by the peer-to-peer process? So other than the first three layers, the other layers will be having an communication should be in a direct manner. Though other than first three layers, all the other layers are having the peer-to-peer process because it doesn't having any intermediate nodes. At the highest layers, however, the communication has to brought between the device A to device B and back to the other layers. So for sending the devices to own information, and the receiver has to receive the information, for all the things we are having a peer-to-peer process. So in this peer-to-peer process, as I said before, there is no intermediate communication will be used. Only here the devices are having a direct communication. So at layer 1, that entire package is converted to from form that can be transmitted to the receiving devices. So it should be converted and directly it should be transmitted to the receiving device. So here the wrapping and unwrapping process will be continued. That is, we can call it as an encapsulation and decapsulation because here we are not having any intermediate devices. So this is about, and we can see what we discussed, layered architecture as well as the peer-to-peer communication. It is a complete OSI model architecture. Here you can see all the 7 layers, sender and the receiver, that we can call it as a device A and device B. Only the first 3 layers will be having an intermediate nodes, and other from the 4th layer to the 7th layer it doesn't having an intermediate node, it is having the peer-to-peer process. So each layer will depending upon the other layers. So for physical and data link layer we having 1 to 2 interface, and the data link to network will be having 3 to 2 interface. So this plays a major role in an OSI model. So this is the complete architecture of an OSI model. So let me discuss each layers in detail. Before that, discuss about the layer, we need to know the concept of encapsulation. So what is mean by encapsulations? A packet at level 7 is encapsulated in the packet at level 6. So all the levels are doing the same thing. The packet 5 is encapsulated in a packet 6, packet 4 in 5, 3 in 4, 2 in 1. That is why we can be having 1 to 2 interface, 3 to 2 interface. In this diagram you can see that interface. That is why we are having like this. So the overall we are having the data portion of a packet at level n-1 carries the whole packet from the level n. So this concept we can call it as an encapsulation. So let me discuss in this session. We can briefly describe the functions and how each layer will influences to the other layer. So let me discuss each layer in the detail. We are going to discuss about the 7 layers of an OSI model. The first one is a physical layer. So what is the main responsibility of a physical layer? The physical layer is responsible for movement of individual bits from one node to another node, or we can say it as one hop to the next hop. Mainly the physical layer carries the stream of bits. It carries an bit stream over a physical medium. It deals with the mechanical and electrical specification of the interfaces for the transmission medium. It is having the transmission medium. Through this transmission medium it carries a stream of bits. So what is that stream of bits? It also defines the procedures and function that the physical devices and interface have to perform for a transmission. So it is the main responsibility of the physical layer is to move the individual bits from one node to the another node. So So this is the diagram of a physical layer. So here from the data link layer to the physical layer, it carries a stream of bits through the transmission medium. It is carrying the physical layer to the, and then from the receiver side, the stream of bits are entered into the physical layer. The physical layer delivers the stream of bits to the data link layer. The responsibilities. What are the responsibilities of a physical layer? The first responsibility is a transmission medium. For sending and the receiving the data, here it is used as a transmission medium. And the representation of bits, here everything should be represented in the form of bits. That is, we can call it a sequence of zeros and ones with no interpretation. And the data rate. So each second, the number of bits that can be carried in each second is known as data rate. In synchronization of bit, the sender and the receiver not only must use the same bit rate but also be synchronized at the bit level. That is why here we are having a synchronization of bits. And physical topology, how the devices are connected to each other, that can be defined by using an physical topology. And transmission mode, the transmission mode can occur between the two devices in either it may be a simplex, half duplex or full duplexes. So this is the major responsibilities of a physical layer. The next one is about a data link layer. The data link layer transforms the physical layer, that is a raw transmission facility, to a reliable link. So it makes the physical layer appear error-free to the upper layer. So the main responsibility of the data link layer is to move the frames from one node to the another node. The main responsibility of the physical layer is to move the bits. In the data link layer, the bits are encapsulated into the frames, and then the frames can be moved from one node to the another node. So this is the major responsibility in the data link layer. So here you can see the data link layer diagram. From the network layer, it gets the data. Here it adds the header to the each frame and trailer to the each frame. That is why we will be having header H2D2, because it is a second layer. That is why we are using the number called H2D2. To the physical layer, it is giving the data. Then the frames are from the physical layer, it is given to the data link layer, and the data link layer, it is transformed to the network layer. So this process will be continued. Then we discuss about the responsibilities of an data link layer. So the data link layer divides the stream of bits received from the network layer into a manageable bitscom frame. So the stream of bits are divided into frames. And physical addressing in the set, it adds an header frame to define the sender address and the receiver address. The flow control, error control and access controls are the major responsibilities of a data link layer. The flow control is to avoid the overwhelm of the receiver. We are having a flow control. And the error control to check the reliability concerns and any other affix that can be protected from the error control. And the access control, when two or more devices are connected to the same link, the data link protocols are necessary to determine which device has the control over the link at the given time. So which device has to access the link at the present time, that can be defined by the access control. So we have seen that this data link layer can use the hop-to-hop delivery. So this is a hop-to-hop delivery. Hop-to-hop in the sense we can it transfer the data to the node to node, from A to B, B to E and E to F. So each layer it is having an hop-to-hop delivery. Here you can see this hop-to-hop delivery is performed. The next layer is a network layer. So the network layer is mainly responsible for source to destination delivery of packets. First layer is for bits, second layer is for frames, and third layer is for frames. This concept we have to remember till the end. So source to destination delivery of packet, possibly across multiple networks. So whereas the data link layer delivery of packets between two systems on the same networks. So the network layer ensures that each packets from its point to the origin to its final destination. So if two systems are connected to the same link, there is no usually need for network layer. However, if two systems attach to two different systems, we need to connect the devices between the network of links from the source to destination delivery. So there are the major things we need to concentrate in the network layer. So this is the diagram of an network layer. So in this diagram you can clearly see this how the packets are transferred from one to the another. Same, it is gets the data from the transport layer, it adds the header and it is transferred to the transport layer. From both sender side and the receiver side it is happening. And responsibilities includes logical addressing and routing. So the network layer adds a header to the packet coming from the upper layer, and it includes the logical addressing of the sender and the receiver. So that's why the sender can know that's why the receiver can know which sender can send the data. And the second one is in routing. The routers are switch the packets to the final destination to the connecting devices. So the mainly for connecting devices where it has to reach the destination. So that includes an responsibility of a routing. So that is why about an network. So here we said that network layer there will be having a source to destination delivery. So in the source to destination delivery there is a direct from one source to the destination. So there it will be from in system A to it deliver the process to the communications to the F. So from A to F there will be having a source to destination delivery. So from node to node, in the sense we can say that it is a hop to hop delivery, but it's a direct link between A to F. So we can call it as a source to destination delivery. Then next one is about a transport layer. So what is the main responsibility of the transport layer? It is for mainly process to process delivery. There we can discuss about a source to destination delivery. Here it includes a process to process delivery. So process in the sense it is an application program that is running in the host. So whereas the network layer oversees source to destination delivery of individual packets, so it does not recognize any relationship between those packets. So at the transport layer, on the other hand, it ensures that the whole message is arrived in time to having the both error control and flow control at the source to destination level. So that should not be recognized in the network layer. So this is the transport layer. It receives all the data from the session layer and it adds the headers, then it transfers to the network layer. In the transport layer, it performs the segments. So the data are sent as a segments. So each segment will be finally transmitted to the session layer. The responsibilities are service point addressing. First one is about the service point addressing. The transport layer header must therefore include the type of address. We can call it as a service point address. So the network layer gets each packet to the computer and the transport layer gets the entire message to the correct process on that computer. That is the major difference between the network layer and the transport layer. And segmentation and reassembly, here the packets are divided into one manageable data units that are called and segments. It contains a sequence number as well. The third responsibility, as we said before, connection control, flow control and error control. The flow control does not overwhelm the receiver, and the error control is to avoid that entire message is received in a correct way. There is no damage, loss or duplication. And what is this connection control? Either it is connectionless or connection oriented, to ensure that we are having an connection control in the transport layer. And the next layer is about an session layer. So the services provided by the first three layers, physical, data link and network, are sufficient for some processes. For a small processor, it is enough to carry all the services, but from some processor, it does not sufficient. To make more efficient, the session layer includes a dialogue controller. So it establishes, maintains, and synchronizes the interaction among the communication system. The session layer is mainly responsible for dialogue control and synchronization. So this is about a session layer. It receives the data from the presentation layer, and here it adds synchronizations to the each data that could be transferred to the transport layer. From the transport layer at the receiver side, it transfers to the session layer, and session layer will deliver each to the presentation layer. So this responsibilities, dialogue controls. Dialogue control in the sense it allows the communication between the two processes to take place in either half duplex or full duplex, either one way at a time or two ways at a time. Synchronization in the sense it adds the checkpoints to the each streams of data. So for example, if the system is sending a file 2000 pages, if it is advertisable to insert checkpoints after every 100 pages to ensure that 100 page unit is received and acknowledged independently. So each we cannot acknowledge all 2000 pages. To acknowledge that, the first 100 pages and second the 100 will be used as in synchronization or checkpoints. So that is the major advantage in the transport layer. The next one is an presentation layer. The presentation is mainly concerned with the syntax and semantics of the information exchange between the two systems. Thus, the presentation layer is mainly responsible for translation, compression and encryption. Here you will be having the diagram of the presentation layer. From the presentation application layer, it receives the data and it adds the header and it's transferred to the session layers. Like the other layers, it is also performing, but it includes the syntax and semantics of the information. And responsibilities include translation, encryption and compression. So what is meant by translation? The sender exchanges the information from its sender dependent format into a common format, and the receiver machine changes the common format into a receiver dependent format. The sender will be having the sender dependent format and the receiver will be having the receiver dependent format. And the encryption means the sender transforms the original information to another form and sends the resulting message out over the network. Compression, data compression reduces the number of bits contained in the information. The last one is an application layer. The application layer enables the user, whether a human or a software, to access the network. To provide the user interfaces and the support for services such as electronic mail, remote file access and transfer, shared database management and other type of distributed information services it uses. So the application layer is mainly responsible for providing the services to the user. So this is a top layer. So it provides the services to the users. Here will be having the diagram. From the user it gets all the data. That data can be in any format. That message can be used some dialogue control systems. To the presentation layer it gives, and from the application presentation layer it gets the data from the application layer. Then the application layer delivers the programs to the user. So this process will be continue to deliver all the messages to the user. The main responsibilities of an application layer is, first one is a network virtual terminal. It allows users to log on to the remote host. File transfer, access and management is the second responsibility. It allows all these three systems to in the remote control to access and manage the computer locally. And mail services, the application provide emailing, forwarding and storaging services. That is all about include mail services. And directory services provides distributed database source and access for global information about various objects and services. So this is about a summary of each layers. Here you can see this physical layer is transformed from mechanical and transformation bits over the medium. Data link layer is for stream of bits. Network is for packets. Transport is for process to process delivery. Session is for to establish, manage and terminate the sessions. Presentation is for translate, encryption, compression of data, and application layer is mainly used for network of resources in the remote control. So these are all the summary of and each layers. So that's all about an OSI model. We have detailedly discussed about OSI model and each layers with a neat diagram. So that's about a summary. Thank you for watching the lecture. Thank you.